So this question is from winter 2019 examination of GTU for the subject basic electrical engineering. So the question is like this: a 100-volt 60-watt bulb is to be operated from 220-volt supply. What is the resistance to be connected in series with the bulb to glow normally? So this is a 4 marks question. So we have a bulb and it should be connected in series with some resistance so that it can glow to normally. Our supply is 220 volt. So we can draw the circuit diagram like this. This is 220 volt supply. The rating of our bulb is 100 volt 60 watt, and we want to find the value of this resistance. So whenever the rating of the bulb is given like this, so this is the rating of the bulb. So at this rating the bulb will operate normally. So the power of the bulb is 60 watt and the rated voltage of the bulb is 100 volt. This is rated power of the bulb and this is rated voltage of the bulb. So from this we can get rated current of the bulb. So the rated current will be P by V and is equal to 60 by 100 and is equal to 0.6. This is rated current. So to operate this bulb normally, rated current should flow through the bulb and rated voltage, that is 100 volt, should be applied across the bulb. So the rated current is 0.6 ampere. So in this circuit diagram, if you want to have a 0.6 ampere current, the resistance of the circuit should be accordingly. We will find the value of the resistance, total resistance for the circuit, and from that we will get the value of the resistance required to be found. So the resistance of the bulb will be, for example, let us take it as R1. So we can find the value of the R1. R1 is equal to V square upon P. We have the equation of P, power is equal to voltage square divided by resistance. So utilizing this equation we can have the value of resistance R1. This is the resistance of the bulb. So the voltage is 100 square and the power is 60. So 100 into 100 divided by 60, 0 0 cancel out. This would be 500 by 3. It is in ohm, or we can write as 166.67 ohm. So this is the value of R1. We want to find the value of R. So the current of the circuit is 0.6 ampere. And we can have the total resistance 500 by 3 plus R, and the supply voltage is 220 volt. So we can get the value of R. It is like this. We can put the equation in this way: voltage divided by total resistance, that is 500 by 3 plus R, and this should be equal to 0.6 ampere. Voltage divided by resistor, that is 0.6. So we can write like this: 220 is equal to 0.6 into 500 by 3 plus 0.6 into R. So this would be like 220 is equal to 100 plus 0.6 R. So from this we can get the value of R. R is equal to 220 minus 100 divided by 0.6. So value of R is 200 ohm. So now there is another method, and which is far simpler than the previous one. We have the rated voltage of the bulb, that is 100 volt, rated power of the bulb, that is 60 watt, and we have calculated rated current for the bulb, that is 0.6 ampere. Now to operate the bulb at normal values, that is normally the rated voltage, that is 100 volt, will be applied across the bulb. Now the resistor is connected in series with the bulb, and both are supplied by 220 volt supply. So the remaining voltage, that is 120 volt, will appear across the resistor. We don't know the value of the resistor, but we know the value of the current that is flowing through the resistor, that is 0.6 ampere. So we know the value of the current, we know the value of the voltage. So we can find the value of the resistors using Ohm's law. So it would be voltage divided by current, that is 200 ohm. So this is simpler method if you understand the voltage division.